Okay. Hello, everyone, and thank you for joining us in this session, which is about Arabic NLP. I'm Lama, PhD student in Lancaster University under supervision of Dr. Paul Ryson. My talk is about developing an Arabic infectious diseases ontology to include non-standard terminology to support various important applications, including the monitoring of infectious diseases. It's a part of my PhD study, which is about using Twitter to support analysis of the spread infectious diseases. First, I will explain the purpose and motivation of this work. The Arabic infectious diseases ontology is classified as a domain ontology, whereas the concept and relation belong to a specific domain. Here is the infectious diseases. The overall goal of the infectious disease ontology is to be a key source of information related to infectious diseases in Arabic. It can be used for many important applications in academic or a real world. It will be described the terms and relation necessary to detect and analyze the infectious diseases. It will be bridge between informal terms and scientific terms, and it will be realized in the form that will be freely available. In this, here is the QR code of the ontology that will be already published in the DOI of the Lancaster University. On this figure, we can see the steps of building the ontology. We followed a hybrid approach which married the two techniques, manual ontology development with ontology learning. I will give a small explanation here and will be details in each steps. First, we determine the ontology structures. Then we defined a list of infectious diseases based on information from World Health Organization website. Then we developed a web crawler that retrieved relevant documents from trusted websites that represent government organizations or hospital. We do later web cleaning. We building the corpus. Here we have 115 documents that covered around 25 infectious diseases. After that, we do the pre-processing, term extractions, finding synonyms, adding informal terms, obtaining concept, defining relation, update the relation. Sorry about that. Decide the relation, and finally ontology evaluation. As I said, we defined the list of infectious diseases depend on the information in the World Health Organization. Then we developed a web crawler. Then we do some pre-processing, include tokenization, normalization, and stop word removal. Finally, we do a part of speech tagging and sentence splitting. We followed three statistical strategies for extract terms, which are TF-IDF, C-value, and YAKE. The TF-IDF, it's a well-defined formula which represents term frequency inverse document frequency. It's used to rank the candidate terms according to the importance in the corpus. The C-value is a multi-word terms to find by the method automatic term extractions. The YAKE, which represents yet another keyword structure, is unsupervised approach for automatic keyword extraction used for text features. Then we used AWN, which represent Arabic word net, to find all synonyms related to the terms in order to expand the terms. After that, we adding informal terms by doing a questionnaire was sent to different types to a native speakers in order to find the slang terms related to infectious diseases. For example, there is a disease which name Humma al-Danak, which is a danger fever in English, has 6 informal names, which is Ad-Dinjiya, Abu Rukab, Ad-Danj, Ad-Danak, Humma Taksir al-Idham, and Humma Aden. Then, to decide which terms to be considered as a concept and included in output ontology, we manually filter the terms that are meaningful. This table shows the basic concept of the ontology. The ontology focus on the infectious diseases concept due to the fact that it represents the central node in the ontology. Diseases and the infected category. After that, we define the appropriate relations for the infectious diseases domain, and this step is done manually. The relations are defined after studying the goal of the ontology. In order to expand our ontology with all terms and relation, we also reviewed an infectious diseases ontology and translated the concept and relation to Arabic. Then we update our ontology with this information. This table represents the relation with Arabic examples and description of the relation. For example, here the relation infected by, it's from infectious diseases concept to infection class. There is also, for example, a relation treats. It's from treatment class to infectious diseases, and so on. We stored our ontology in the web ontology language format in order to support sharing and reuse this valuable resource. We used Portugais tool, which is a free open source software tools typically used for building and maintaining ontologies, and also support many languages like Arabic. This figure shows a subgraph of the developed ontology, which with their classes and their relationships. Here is the central is the name of the infectious diseases, and here is the another concept with the translation will be here, and the details are in the paper. Finally, for the ontology evaluation, we developed 2 strategies to evaluate the ontology. Here we conducted the performance of the term extraction techniques and domain expert evaluation approach. For the ontology evaluation of our term extractions, the term extracting ontology are manually reviewed. Then we compared the extracted term by 3 strategies, which is TF-IDF, C-value, and YAKE, to the final concept using the standard precision core, recall, and F-measure. We can see in this figure, which visualizes the average result of the term extraction performance, and there is a table on the paper for more details. We can see that the lowest performance was found in the C-value method. This could be a result of the complexity of the information of infectious diseases in Arabic language and the document size. The TF-IDF method, which is here in the blue, achieved between 20% to 50% in the result due to the different types of the document included. In the YAKE, the overall performance for the precision is around 35%, and the recall achieved up to 62% in some documents. techniques is ontology evaluation by expert. We ask an expert in infectious diseases who is an Arabic native speaker to evaluate our ontology in terms of medical correction. The evaluation includes reviewing the concept and the relation between the diseases. We calculated the precision of the system after computing the average number of the correct terms, which is 88.4%. This result shows the ontology's high correctness agreed from the expert. In the conclusion and future work, in this paper, we have described an overview resource that integrate the scientific vocabulary of infectious diseases with the informal equivalent. The Arabic infectious diseases ontology is written in Arabic language, and it's the first ontology in Arabic specializing in infectious diseases domain. It contains 11 classes, 21 object properties, 11 data types properties, and 215 individual concepts. Our focus on this paper is to implement the Arabic infectious diseases ontology to support the analysis of the spread of infectious diseases in the Arab country. Some directions of the future work, including expanding the ontology to other diseases in order to build an Arabic ontology that covers all kinds of diseases. In addition, we could explore cross-linguistic research by connecting the Arabic ontology with the English one. Finally, there is a need to enhance the method of the ontology learning for extracting terms and relation. Here is the paper reference, which is published in the LREC conference website. Thank you for your listening. And if you have any question, you can type them in the chat, and I'm happy to answer them after my friend Isra presents her work. If you don't have a chance to ask your question today, or if you need any details later, you can email me.